So, we will demonstrate some experiment on interference. So, to understand those experiment, some basic concept of interference of light or waves should be clear. So, I will take few lectures on the basic concept of interference of light. Okay. So, basically we know that superposition of waves, what is the principle of superposition of waves? So, that is very important to see some phenomena. So, principle of superposition states that whenever two or more waves travelling through the same medium at the same time, the net displacement at any point in space or time is simply the sum of the individual wave displacement. Okay. So, they do not disturb each other. Okay. So, just superposition, principle of superposition states that if two or more waves, if they superimpose, so just simply it will be the summation of the two individual wave displacement. So, travelling wave, we express this y as a function of x t. So, basically when waves is travelling, so this displacement is basically the if it is travelling through the medium. So, this is a displacement of the particle as a function of x and t. So, that displacement is expressed as a sin k x minus omega t plus phi. So, a is the amplitude and k is the wave vector 2 pi by lambda. So, it is a function of x. So, this x is there and minus omega t, omega is the angular velocity, 2 pi by t plus phi, phi is the initial phase. Okay. So, it is a function of x and t. So, there are two periodicity, one is in space. So, there k is 2 pi by lambda. So, lambda is the wavelength. So, that is the periodicity in the space and omega is 2 pi by t, capital T, time period. So, periodicity in time, that is t, capital T, time period. Okay. So, superposition of two travelling waves is basically if these two waves, the displacement is y 1 and y 2. So, their resultant of this superposition, that will be, if it is expressed as a y. So, y as a function of x t will be equal to y 1 plus y 2. Okay. So, depending on the direction of the two waves as well as their periodicity, time period or wavelength. Okay. Depending on that, there are different phenomena we see. So, mainly three phenomena we see distinctly due to superposition. So, one of them is the interference effect. We see when we see the two waves of same frequency and wavelength, but the amplitude may be same or different. Okay. So, are travelling in same direction keeping the initial phase phi constant. Okay. If the two waves obey this condition, then we see the interference effect. Okay. So, basically the two waves following this condition, their frequency and wavelength are same. So, kx omega t, they are traveling in same direction. So, both are having negative sign. They have constant phase difference. Okay. Here is a phi 1, here is a phi 2. They have constant phase, initial phase. Okay. So, their amplitude may be same or may be different. Okay. So, I have taken here A1, A2. So, this resultant y, whatever displacement we will get. So, in that displacement basically we will see the effect, interference effect. Okay. So, that elaborately we will discuss this part, but before that, what are the two phenomena we see from this superposition of waves? Another phenomena that we see, that is the standing wave formation. Standing wave formation, when we see a travelling wave moves from one place to another, whereas a standing wave appears to stand still, vibrating in place. Okay. So, that is a standing wave and travelling wave. Okay. Now, two waves of same frequency, wavelength and of same amplitude are travelling in opposite direction. Okay. So, in case of interference, they are travelling in the same direction. Now, in this case they are travelling in opposite direction. In case of interference, there the two that amplitude of these two waves may be same or maybe they are different, but they are closely same, approximately they are equal, but may not be equal. Okay. So, but in this case strictly it should be equal, amplitude should be equal and it will travel in opposite direction. Okay. So, in that case, due to the superposition of these two waves, this type of two waves, okay, will form the standing waves. Okay. So, in this case, that y as a function of x resultant one after superposition. So, that will be equal to a sin k x minus omega t, okay, plus a sin k x plus omega t. So, they are moving in opposite direction. So, that is a sin r. In case of interference, their sign was same, now sign are different. Okay. So, from here basically sin A plus sin B. So, 2 sin A plus B by 2 cos A minus B by 2. So, this type of relation, trigonometric relation, you know. So, from there you will get basically 2A sin k x cos omega t. So, basically here what we are seeing, so this time part and this space part. So, now they are separated. Okay. These two terms are separated. Here it was this and now they are separated. So, here one can think that this part is the, so A sin omega t by A cos omega t, that generally this is the oscillation. Okay. So, this equation of oscillation, okay, something is oscillating. So, here from here you can tell that so it is not travelling wave anymore. Okay. So, it is just some oscillation with this amplitude, So, it is oscillating in same place, it is oscillating. Okay. But what is oscillating here? So, this part basically it is oscillating with time in same place, means not same place, this pattern, this amplitude, this part is amplitude, but this amplitude is its form is like this, its form is like this, sine form, sine kx, sine form. Okay. So, this form, this is the amplitude as a whole. Now, this part is oscillating, this part is oscillating. So, when it is oscillating, so it looks like this. Okay. So, as if, so this point never will move, will oscillate, and this point always it will oscillate with the maximum amplitude, okay, maximum displacement. Okay. So, this is called this where this there will not be any movement. So, that point is called the nodes, and where maximum displacement, so that part is called antinode. Okay. So, these are statics, these are the characteristics of the standing wave. We see the node and antinode. Okay. So, this is the basically standing wave, and then third one is beat. Also, we are quite familiar with this. So, due to the superposition of two waves, so we get this another phenomena. So, that is called beat. So, what is, so when we get two waves of different frequency and wavelength, but same amplitude and same velocity in same medium. So, same velocity because they are in same medium or traveling in the same direction. So, in this case basically other two cases their frequency wavelength was same, but in this case frequency and wavelength are different for two waves, and other part is same, their amplitude are same and they are traveling in same direction. So, in case of only standing wave, they are traveling in opposite direction, but other two cases traveling in same direction. Okay. So, due to superposition of these two these types of two waves following this condition, so basically we will get the resultant y. So, that is, so a sin y1 plus y2, a sin k1x minus omega 1x plus a sin k2x minus omega 2 t. Okay. So here, so this phase, initial phase part just I have taken as 0. Okay. So, so if you in same direction, so sign also same. So, you will get 2a sin k1 plus k2 x by 2 minus omega 1 plus omega 2 t by 2. Okay. This is the sine part, and cos part k1 minus k2 x by 2 minus omega 1 minus omega 2 t by 2. Okay. So, here actually if we look at the, so when we basically describe wave, you know, at a time we do not look at both x and t, we generally look for a particular x what is happening with t, and then for a particular t what is happening with x. Okay. So, in both cases basically you will see this wave, this pattern, okay, oscillating pattern. Okay. So, here also if we look at the frequency part, so here this 2a is basically now x and t they are not separated, they are not separated. So, in both term it is there. Okay. So, here you are seeing that frequency part, there are two resultant frequency omega 1 plus omega 2 by 2, as if this average frequency of these two waves and difference frequency of the two waves, that is the difference frequency of the two waves. Okay. So, this frequency is difference, means lower frequency, okay, and this is the higher frequency. So, if you plot them, or you can consider that with respect to space and time. So, this part with higher frequency is oscillating like this. Okay. It is oscillating like this. Okay. Its amplitude is not constant, that amplitude, that variation of this amplitude, okay, it depends on the other term, it depends on the another term. So, that variation of amplitude here, it following this another periodicity. So, that is basically omega 1 minus omega 2 by 2. So, here you are getting the two frequency. So, one is this, the oscillating with this higher frequency, and its amplitude is varying, there is a envelope. Okay. So, that is a frequency of this envelope is basically omega 1 minus omega 2 divided by 2. So, that is this part. Okay. So, from here you are seeing basically this amplitude is higher and then very small, amplitude is higher then very small, okay, or 0 higher. And so, as if in case of sound, okay, when this kind of superposition of waves, so suddenly, so periodically you will hear the higher sound or higher intensity, square of the amplitude is the intensity basically. So, that is basically this is called beats. Okay. So, with the period we are getting higher intensity or higher sound. Okay. So, if you count them, so that is the basically it is a number of this beats per second. So, beats we tell beats per second. So, that is basically it is the omega that in terms of frequency. So, that is f1 minus f2, difference of the frequency of the two waves. So, that is the number of beats basically. So, since omega equal to 2 pi f, so omega 1 f1, omega 2 f2. So, difference of this frequency is called the beat. Okay. So, you can count them, from here itself. Okay. So, this phenomena, it's a called beat, and so this due to superposition of two or more waves, okay, under some certain condition we get very prominent phenomena. So, this phenomena, just these three phenomena, this we are quite familiar, and these three phenomena I try to explain you. So, now I will since we are interested for the interference, so I will discuss about the interference effect more. So, let us go back to the interference. So, there what we have seen, y 1 equal to a sin k x minus omega t plus phi 1, y 2 a sin k x minus omega t plus phi 2. So, superposition of these two travelling wave will give us 2 a sin k x minus omega t plus phi 1 plus phi 2 by 2, or this sin A plus sin B. Okay. So, 2 sin A plus B by 2 sin cos A minus B by 2. So, from there we are getting two terms, one is this term and another is this term. Okay. So, 2A, this the cos phi 1 minus phi 2 by 2, there is no x and t term here. So, this we can take as amplitude sin kx minus omega t plus say phi. Okay. Phi 1 plus phi 2 by 2. So, this is a one phase. So, this again it is a travelling wave, right. This is a travelling wave, but its amplitude is this. So, its amplitude you can see, due to superposition like this, we are getting amplitude part. The amplitude depends on the phase difference of the two waves. Okay. So, amplitude is very sensitive to the phase difference of the two waves. So, this is the very interesting part, and we get the interference phase because of this term. Okay. So, if this is the amplitude part, so we will get the intensity. So, that is square of the amplitude. So, we can write I equal to 2A cos phi. So, here in general I have written 2A cos phi. Okay. So, phi is basically your phi 1 minus phi 2 by 2. So, just we are considering this is a phi. Okay. So, this is a phase difference between two waves whatever we have taken, or it is a half of that. So, but in general, so we have taken that is phi, phase difference between two waves. So, square of this amplitude is the intensity. So, that is 4 A square cos square phi. Okay. So, intensity of this one A square, amplitude square, other one amplitude A, they can be different or they can be same. We have taken same. So, just for simplicity, okay, one can take different also. So, if we add them individually, add their intensity individually, so it will be 2A square, whereas here due to superposition of these two one, okay, it is a amplitude superposition, okay, it is not intensity. So, their phase part is very important. So, intensity is 4A square cos square phi. So, variation of intensity due to superposition of these types of wave, whatever we have mentioned, following that condition. So, we will get the variation of intensity as a function of phi. So, it will follow the cos square phi. Okay. Variation of intensity I. So, maximum will be when phi is 0. So, cos square phi 1. So, 4A square. So, maximum intensity will be 4A square. Then minimum when phi is 90 degree. So, it is 0. Okay. So, it is 0. Then again when it is pi, phase is pi, phase difference. So, then you will get minus 1, square of minus 1 is plus 1. So, whatever the cos function, so it is in both side plus minus. Now, in this case it is in one side. Okay. So, variation of intensity will be like this, they are equispaced. So, 0 intensity, maximum intensity. So, this kind of pattern we will see, and that is called basically interference fringe. So, we will get basically bright, dark. bright, dark, this kind of variation of intensity. If it is light, okay, for other wave also one can see if it is light. So, then you will see the variation of intensity of light, visible light, we can observe it. So, here important fact, what is the important fact? It depends on phase, and yes, it depends on phase, and this phase difference should be constant all the time, it should be constant. So, this phi should not be, this phi should not be function of time or space. Okay. So, it is for a particular time and for a particular space, or for So, whatever the so phase difference wherever at a particular time, at a particular space, this whatever the phase difference between these two waves, okay, it will remain constant. So, that phase may vary not at the same place, like at the starting point, okay, whatever the phase between these two. So, all the time at the starting at that place, this phase difference will remain constant. Now, when they are moving, so in another point when they are reaching, so their phase difference may be different, okay, but at that point it will be independent of time, all the time it will remain constant. Okay. So, at different space, at different place, okay, when these two waves will reach, the phase difference between these two waves, that can be different from the another point, another space, okay, another place, okay, but at that place the phase difference will be independent of time. If so, if that is the necessary condition to see this type of contrast of brightness, to see the, so that is called interference fringe, okay, to see the interference fringe, okay. So, this condition is very much necessary. So, it is independent of time, it may vary with space to space, okay, but with time in those places it will remain constant. Okay. So, so that I try to explain here. So, basically if you see that two source, so two waves, it is generating two waves, okay, these two waves. So, their travelling wave, they have same time period and same space period, okay, means wavelength and frequency are same for these two waves. Amplitude also I have taken same, but it could be slightly different, okay. And their phase here, so this initial phase of this one is say phi 1, and at this point it is phi 2. Okay. So, if you, so this source will emit light in different direction, So, wherever the direction, it does not matter, but their frequency and wavelength will remain same, and at this point here this its phase, it will remain same for all the time, that will be phi 1, okay, and here phi 2. Okay. So, two waves are coming this way. So, when they will reach here, So, this is a screen. When they will reach here, one is here, another here. So, here also their phase, its phase here, this is a phi 1, whatever the phase was here. So, here it will remain phi 1 and here it will remain this phase phi 2. So, these two are parallel, same frequency and same wavelength. So, their phase at all these are basically is the wavefront the phase remain constant, okay, or remain same on the wavefront. Okay. So, so here what will happen? So, one light is this, but these two will not interfere, okay, because there is no superposition of these two. Now, this light, this wave and another wave, I have not drawn this way, but you can consider another wave from this source, okay, reaching here. At this point there will be superposition of these two. So, they are moving in same direction, you can say this, okay. So, in positive direction, say, not in opposite direction. So, here the phase of this one is phi 1 and phase of this one, here it was phi 2. Now, here there will be this phi 2 will be phi 2 plus 2 pi by lambda s to p. What is s to p? S to p. So, this basically this one is travelling additional path compared to this one. Okay. So, when they are travelling the same path, so their phase remain intact. Okay. So, but this part if you just draw a normal on it, so this side their path are same, okay, of these two waves, but here this will be the additional, this S to P will be additional path in this wave. So, so phase for this path will be 2 pi by lambda into this path. Okay. So, it is here when it will reach. So, whatever phi 2 that is there and due to additional path. So, this term will be added. So, here basically at this point this phase difference between these two is not phi 1 minus phi 2, it is different one, or phi 2 minus phi 1, it is not that difference of the initial one. So, additional phase difference is coming. Okay. So, now phase difference are different. So, if you consider the different point of superposition, so this phase difference will be different, but at this point all the time phase difference remain constant. Okay. Although phase difference are different compared to here, okay, but here another place, at that place the phase difference will be independent of time, it will remain constant. So, phase difference are varying in space, okay, but at each place it will remain constant for all the time. Okay. So, that is the condition if two source follows this, two waves follows this condition. So, then we tell these two sources are coherent. So, that is the definition of coherent. The phase difference remain constant, phase difference remain constant between these two waves. So, it is not that the same phase here it will remain constant here, but in other place phase difference remain constant between these two as a function of time. Okay. But it varies, point to point it varies. Okay. and that variation will give in space the variation of brightness of the light, variation of brightness of light on space. So, that is nothing but the and that pattern is independent of time. Okay. So, so that is called the basically interference fringe, and thus interference fringe is formed in a space, and that is independent of time. Okay. That you get only when these two sources are coherent, and this is the condition of coherent whatever so far I have discussed. Now, this phase difference when these two, so these two coherent source, so from there these two waves meet here. Okay. So, always to see the brightness, degree of brightness, you have to find out the phase difference. Okay. So, degree of brightness will depend on the phase difference or path difference. So, phase difference here is phi equal to so this phi 2 plus 2 pi by lambda s to p minus phi 1. Okay. So, cos square phi, so here this is the phi. So, cos square phi 4a square cos square phi. So, now whether cos square phi will be 0 or cos square phi will be 1. So, when cos square phi will be 0, then due to this phase difference at this point we will get dark, extreme intensity, that is dark, and other case 1 extreme intensity will get, that is bright. Okay. So, when 1. So, when cos term will be 0, so when phi is 2n plus 1 pi by 2. Okay. Phase difference is odd multiple of pi by 2, and it is the even multiple of pi. Okay. Not even multiple, I think odd and even both. Okay. N equal to 0 plus minus 1 plus minus 2 for both cases. Okay. So, so this, for this condition we will get dark, and for this condition we will get bright. So, this phase will depend on this position at this, if wave comes here or these two waves in middle point. Okay. So, path difference or phase difference will be same, path difference or phase difference will be same. So, here you will get the you will get the phi equal to 0 path difference, phase difference. So, phi equal to 0 means that is the 1 maximum intensity. So, then it will vary following this, So, we will get dark bright this side, and from symmetry you will get from in other side also. So, these are called the order of the interference. So, you will get upside as well as downside also. Okay. So, this path difference is to p, one can calculate this, very important. So, just as I told that, just draw a normal. So, if this angle, so here if this angle is theta, okay. So, here we can consider, so from this middle point of this source, two source, so if you draw a line, so these two angle will be same. So, approximately for you can take, so this from the center point, as I told here, where from middle point, so if the distance is x, so this x by the distance of the source and the screen, if it is capital D, so basically x by d, that is the tan theta, and sin theta will be s to p by this. Okay. Sin theta will be, if this is theta, this is normal, so s to p by small d. So, this small d is basically distance between two source. So, Now, for small theta approximately you can write this sin theta. Okay, that is the approximation we have taken. So, basically this will be equal to this. So, S to P will be x d capital D. So, this path difference will depend on the from the center point of the screen. Okay, what is the at which distance you are taking, that x, and this d is the distance between two coherent source, and capital D is the distance between the source and the screen. Okay. So, so these are the condition, these are the path difference. Now, so path difference actually will depend on basically x if these two other remain constant. So, that is why on the screen this x are varying. So, we will get this phi 1 phi 2 remain constant all the time. So, this bright and dark, that will depend on this S to P, means on this x. Okay. So, on the screen basically we will see the variation of the intensity. So, dark bright pattern we will get. So, these are very useful and derivation for the interference. In many places we will use this one. Okay. So, I will stop here, I will continue in next class. Thank you.